Hello. In this video we're going to be talking about the standard form for quadratic functions. So the skeleton formula for a standard form quadratic function, still making a parabola if we were to graph it, f of x equals a times x squared plus b times x plus c. A, b, and c are the coefficients for this function, and note that a cannot be equal to 0. So what the standard form can show us right away is the y-intercept of our graph. The value c, the constant added on at the end, the number that's not multiplied by an x, that value is going to be where we cross the y-axis when we graph this parabola. We can also calculate the axis of symmetry for this. The axis of symmetry follows the pattern x equals negative b over 2a, or the opposite of b over 2a. So we figure out what our a value is, what our b value is, we do the opposite of b and divide it by 2a, x equals that number is the axis of symmetry. Now, knowing that the axis of symmetry cuts our parabola in half, the axis of symmetry also goes through the vertex. So the x-coordinate of the vertex is the exact same thing as the opposite of b over 2a. Let's apply some of these principles to our next set of questions here. In this example, we want to graph the function f of x equals 3x squared plus 6x minus 4. We're also going to give some information about it that will actually help us do that graphing. So we want to name the axis of symmetry, the vertex, and the y-intercept as well. Before we do that, I want to identify the values of a, b, and c. A is the number that's multiplied by the x squared term, which is 3. B is the number multiplied by the x term, 6. C is the number or just sitting at the end there without an x next to it, it's negative 4. Then, going from there, to find the axis of symmetry and the vertex, we need to use that equation we had, negative b over 2a. So the opposite of b would be negative 6, and then 2 times the a value is 3. Well, 2 times 3 is 6, so we have negative 6 over 6, and that value is equal to negative 1. So we can list one thing we know right now. The axis of symmetry is x equals negative 1. We also can quickly give the y-intercept. The y-intercept is the same as the c value. So we're going to cross the y-axis at negative 4. That ordered pair would be 0, negative 4. The vertex then. The vertex is found, well, we know the x-coordinate of the vertex is the same as that negative b over 2a value. So I want to plug in negative 1 for x and figure out what y equals. So I have 3 times negative 1 squared plus 6 times negative 1 minus 4. Negative 1 squared is 1 times 3 makes 3. 6 times negative 1 is minus 6, and then minus 4. 3 minus 6 minus 4 equals a value of negative 7. So my vertex, we had an x value of negative 1, a y value of negative 7 that we just found. So we know that information. Let's use that in order to find the table of values to graph the function. So I'm going to start by making our xy chart, or f of x chart. Because a parabola is symmetrical, with the vertex kind of in the middle of that symmetry, I'm going to put the negative 1, negative 7 we just found for my vertex in the middle of my xy chart. And then I'm going to surround the x with numbers next to negative 1. So if I go 1 bigger, I'm at 0. 1 bigger again, I'm at 1. And if we go 1 smaller in each direction, we're at negative 2 and negative 3 respectively. Then we're going to plug those numbers in to x to find what y is. So let's start with f of 1. F of 1 is 3 times 1 squared plus 6 times 1 minus 4. 1 squared is 1, times 3 makes 3. 6 times 1 is 6, with a minus 4 at the end. 3 plus 6 makes 9. 9 minus 4 makes 5. So we have 1 comma 5. We put 1 in, we got 5 out. Because it's symmetrical, negative 3 should also output 5. Let's do 0 next. F of 0. So we do 3 times 0 squared plus 6 times 0 minus 4. 0 squared is 0, times 3 makes 0. 6 times 0 is 0, minus 4. And of course, it's negative 4. We already knew that 0, negative 4 was a point on here. So that means negative 2 comma negative 4 must also be 1. All right, let's graph these points. So we have a point at negative 1, negative 7. It's right there. I have a point at 0, negative 4, as well as at negative 2, negative 4. I have a point at positive 1 comma 5 and at negative 3 comma 5 as well. And so we can use these 5 points to draw in my parabola. And there it is. So that's the graph of the parabola. Let's look at one more. Consider the two parabolas below here. Which one has the larger maximum of the two? So we need to figure out what the two maximums are for these parabolas, and then we will see which one's bigger. So in the function g of x is equal to negative x squared plus 6x minus 4. In that, my a value, the number multiplied by x squared, is a negative 1. B is equal to 6, and c is equal to 4. So I can find the vertex where the maximum occurs by starting off by doing our opposite of b over 2a, which means we do the opposite of 6 over 2 times negative 1. 2 times negative 1 makes negative 2. Negative 6 divided by negative 2 makes positive 3. Then, so I know that the vertex occurs at 3. The maximum then is the y value at that point. So I'm going to do g of 3. So I have a negative 3 squared plus 6 times 3 plus 4. 3 squared is 9, times the negative 1 makes it a negative 9. 6 times 3 makes 18, plus 4 more. Negative 9 plus 18 is 9, plus 4 more makes 13. So g of x has a maximum of 13. Okay, let's look at the next one. In the function f of x, I have the x values given to us here as 4, 3, 2, 1, 0, and the f of x values, the y values, as 10, 13, 14, 13, 10. Notice the symmetrical pattern there. As the y values, they start to grow, they peak at 14, and then they go back down, right? So there's that symmetry here and here. There's that symmetry here and here. So this point must be the vertex, which of course is going to give us where our maximum occurs. And notice that the y value of 14 is the largest y value there is in the graph. All the other ones are lower, and since it's a parabola, it should continue lower. So our function f has a max of 14. So which one has the larger maximum? It's function f. 14, of course, bigger than 13. Okay, so that's us using quadratics in standard form. For now, we are done.